So I left you with this problem to try it on your own. Let's see how it went. I started by drawing a rectangle. I kind of squeezed the entire solution into this small space. So I'm basically going to reveal the whole thing, but hopefully you tried it and we'll see if you got it. So this is my entire answer, like all in that space there. So yeah, if we go through it a little bit at a time. All right, there's my drawing. I've got the length and the width, and they tell me that the width is W equals 6 less than twice the length. So I've got 2 times L minus 6. They also talk about the area. Well, I know the area of a rectangle is length times width. So then I replaced that W with 2L minus 6 right up here. And they said the area was 140. So this ended up being my equation. 140 equals L times 2L minus 6. It's nice to not have the 1/2 here, like in the triangle. So where do we go from there? We'll distribute the L, 2L squared minus 6L, subtract that 140, and you can set up, let's put this a little bit more in the middle so it's a little more in focus. You can set up your quadratic formula from there. I just went ahead and wrote the answers from this. I got L equals 10 and L equals -7. But of course the length cannot be -7, so I just said forget that one. I'll take L equals 10, so I know the length of my rectangle is 10 yards. And if I take that 10 and I plug it back in here, 2 times 10 minus 6, that gives me a width of 14 yards. So there you go. Okay, let's get to the next example problem. Actually, it needs a bit of an introduction. It's called Pythagorean Theorem problems. Well, in my experience, the Pythagorean Theorem is probably the most well-known math theorem. Walk up to just about anybody out on the street of a certain age, high school or older, and they're gonna know the Pythagorean Theorem. So it applies to right triangles. If we label the sides of the right triangle as A, B, and C, and we have to do it in such a way where A and B we say are the legs, which these are interchangeable, both are legs, but A here, B here, or vice versa. C, though, we always think of as the longest side, known as the hypotenuse. Okay. Most people remember hypotenuse. Not as many people remember that these are called the legs. Anyway, if we set it up that way, the Pythagorean theorem says that a squared plus b squared will always equal c squared, which is pretty fascinating. And there's a pretty cool story about the Pythagorean theorem and Pythagoras. I won't go into it here for the sake of our video time. Okay, let's get to that next example problem. I'll go ahead and read it. Example number 2 says a wire 40 feet long runs from the top of a pole. Oh, I don't know if you can hear, my neighbors are racing down our neighborhood. Sorry about that, if that came through the mic. It says a wire 40 feet long runs from the top of a pole to a spot on the ground. If the height of the pole is 5 feet more than the distance from the base of the pole to the spot where the wire is anchored, how tall is the pole? And we'll need to round this to 1 decimal place. Okay, so I'm going to start off with a drawing, and I'm going to get a nice right triangle there. So I'm imagining this as being the ground, and then I've got this pole, maybe like some kind of a thin, very tall, thin, I don't know, telephone pole, I'm not sure. But apparently it needs some support, so it's got this wire attached that runs down to the ground over here to help hold it up. Okay, and I've labeled that wire as being 40. The wire 40 feet long runs from the top of the pole to a spot on the ground. Okay. Then it starts describing the other lengths of the triangle. It says the height of the pole is 5 more than the distance from the base of the pole to the spot where the wire is anchored. Okay, so the height of the pole is 5 more than this length there. So you have to think, well, how should we label our triangle? And I think the best way to do it, if this is 5 more than this, maybe just call this x, which would make this x plus 5. I think that's the most natural way about it. All right, so then this is 5 more than that. And if we know that we've got a right triangle, then, hey, we can apply the Pythagorean theorem. We know that this squared plus this squared is going to equal the hypotenuse squared. And just like that, we've got our equation. X squared plus the quantity x plus 5 squared will equal 40 squared. Okay, once we've got our equation, well, we want to put it in a position where we can use the quadratic formula. So we're going to multiply this out. We need to FOIL here, and we'll square the 40. So I prefer to just write that twice so I know that I'm supposed to FOIL. And I went ahead and did that next. So I've got the first x squared and then all the parts for my foiling there. And 40 squared equals 1600. Okay. And where is this going? Well, I want to combine my like terms. I'm going to subtract the 1600 as well. And that's going to lead me to this equation. I've got 2x squared plus 10x, and then when I subtract my 1600 minus 1575 equals 0. Okay. So really, of course, what's new in this section is just setting up these equations and these drawings. Once we get to this point, well, hopefully this looks really familiar. We're going to plug in our values of a, b, and c to our quadratic formula, and take your time with this. You know, even though we've done it a bunch of times, still be careful to plug the numbers in carefully. A is 2, B is 10, C is negative 1575. It would be a shame to do all of this correctly and then miss a negative sign or who knows what when it comes to the formula. So I'm going to trust that you guys can go about this. We'll go through this relatively quickly to finish it off. Underneath the square root, you get 12,700. And in this particular problem, what we're used to doing, that will not have a nice square root. What we're used to doing is, reducing, maybe pulling out some numbers and taking the square roots, perfect squares. Here, though, the problem tells us to round to 1 decimal place. So I'm actually going to encourage you, don't bother reducing the square root because we're going to get the decimal number anyway. What you do want to do is write the 2 separate forms, right? One with the adding, one with the subtracting. And then calculate both of these numbers. And this is what you'll get for each one. When you're adding and you round to 1 decimal place, that will work out to be x equals 25.7. When you subtract and then divide that whole thing by 4, you should get negative 30.7. So I would please encourage you calculate these numbers yourself. Make sure you can get those decimal numbers. Make sure you know how your calculator works. Because obviously when you go to take this test, I won't be there to help you figure out your calculator, obviously. So try it out now. Make sure you can do these things. Okay, so just like the last problem, we come to this point and we've got two answers. Well, one of them is going to be going to lead us to our final answer. The other one we can disregard. Which one should we keep? Which one can we forget about? And well, yeah, it's the negative one, right? So we're talking about the length of a pole, or the length across the ground. So we just want that positive answer. What is the final answer going to be? Well, it turns out it's not the 25.7. What did they actually ask in the question? They asked, how tall is the pole? And if you remember our drawing, right, we said that was 40. This is x plus 5. The pole is the x plus 5. So we just figured out what x was. That's that distance on the ground. So we should add 5 to answer the question. And it turns out the height of that pole is 30.7 feet. Okay. Now you might be thinking, whoa, wait a second, is there a coincidence here? Well, yes and no. And we don't need to go into those details of why this happened to be the positive version of that, but that is not unusual in these cases. Anyway, really what I want you guys to take away from it, just ignore that answer, right? This is the answer we want, but we know we got to add 5 to it, and we happen to get the positive version of that other thing. Okay, so I want to leave you guys with one to try out here. Let me read it for you. The hypotenuse of a right triangle is 10 centimeters, and one leg is 3 times the length of the other. What are the lengths of the two legs round to 2 decimal places? Okay, give it a try. I'll see you in the next video.